Hi all, how are we doing today? Hi all, how are we doing today? Okay, well, so we're looking at the review for this test. Share screen, start the broadcast. Things are about to become different. There you go. That's me. Okay, I'm sharing my screen as you see, like that. All right, so we're continuing our review from yesterday. Since I have less people, it's going to go by a little faster. But when it comes to next, we're looking at rational functions. And as discussed in class, you only need to be able to find the properties of rational functions. So those properties include the domain, the x and y, the vertical and horizontal asymptotes, the vertical asymptotes, the horizontal asymptotes, the x and y intercepts. That's it. That's all that's required. The x and y intercept. Let's work through two examples of us finding all of those. Probably should be five of them. Oh yeah, x and y intercepts. That's fine. Let's work through two examples of finding these. Let's say I have a function f of x is equals to 2x plus 1 divided by x plus 3 multiplied by x plus 4 right here. And they want me to find, let's start with the domain. To find the domain, you set the denominator not equal to 0. So x plus 3 times x plus 4 cannot be 0. Well, from that right here, you get then that x plus 3 cannot be 0. Subtract 3. Therefore, x cannot be negative 3. On the other hand, you have your x plus 4 cannot be 0. Subtract 4. So therefore, x cannot be negative 4. The only thing that you have to remember is that this is not the answer to the problem. The domain for a function is not that it's not these numbers, is that it is everything else. And so you can give your answer, for example, on a number line. So you have your negative 4 and your negative 3. You have an open circle here and an open circle there, and that is to say that there is no answer there. The actual answers are everywhere else that you shade. So you shade between negative 4 and negative 3, less than negative 4, and greater than 3. Okay? You can give the answer in interval notation, negative infinity to negative 4, which corresponds to the first shading, union, negative 4 to negative 3, which corresponds to the middle, and then negative 3 to infinity, which corresponds to the last area. Of course, you can always give your answer in interval set Euler notation, x such that x can be any number except x cannot be negative 3 and x cannot be negative 4. Each of those are acceptable ways of finding the domain of our function. Now, another example of finding the domain. Let's say I have, I gotta make this up, f of x is equals to 2x over x cubed plus 8x plus x squared plus 15x right here. Oh, excuse me. Good thing you're not around. And I had to find the domain of this function right here. So what I do again is I set the denominator not equal to 0, and then I need to factor out this equation to find that domain. So within here, I can factor out x. leaves me with x squared plus 8x plus 15. Everything loses a power. I need two numbers, and when I multiply them, I get 15. And when I add them, I get 8. Those numbers are 3 and 5, not equal to 0. Therefore, x times x plus 3, x plus 5 cannot be 0. And so therefore, my domain is, I forget, x cannot be 0, x cannot be -3, x cannot be -5. Okay. Again, this right here is the set below notation. That's not a curly bracket. X such that x cannot be -5, x cannot be -3, x cannot be 0. If you don't put the domain on a number line, you have -5, -3, and 0. Again, by the way, you can always pause, and write. It is a video after all. I'm moving a little faster since there's no one else to slow me down. So open circle, open circle, open circle. You shade once, you shade twice, you shade 3 times. Oh, one more. You shade 4 times. The set below notation comes from each of the shadings. And so this first one right here is from -infinity to -5. This one right here, union, -5 to -3. This one right here, union, -3 to 0. And the last one, union, 0 to infinity. And that right here is my domain. Normally I would say any questions, but no questions, I guess. All right, so with that being said, the next thing we need to find are your vertical asymptotes. So we're going to use the same equations throughout to make our lives a little bit easier. So to find the vertical asymptotes for the first one, the VA, f of x is equals to 2x plus 1 divided by, I should write these down, divided by 3, x plus 3, x plus 4, is you first have to reduce the function. Does anything cancel here? No, because the two factors need to be exactly the same to cancel them out. And so now that I've reduced the function, I then set the denominator equal to 0. X plus 4 is equal to 0. And that tells me that x is equal to -3 and that x is equal to -4. This graph has two vertical asymptotes, just like that. In the other one we did, the vertical asymptote, f of x is equals to 2x over x cubed plus 8x squared plus 15x. Right, I gotta simplify this equation. So the first thing I have to do is I have to factor the equation so I can see if there are any like factors. So this is 2 over x, factor out an x. Well, I factored it already. I know it factors into x plus 3, x plus 5. And if you look carefully, you'll see that there is indeed a factor, a common factor. These x's will cancel out. So now my reduced function is just this, x plus 3 times x plus 5. And so now I can set my denominator equal to 0. And so I get x is equal to -3. I get x is equal to -5. This graph again has two vertical asymptotes. So although the domain had 3 pieces to it, the domain was 0, -5, and 3. Because of the simplification, I lost a vertical asymptote. And so this graph ends up only having 2 vertical asymptotes instead of 3. All right. Now, to find the horizontal asymptotes, this little part right here you gotta study. If you know how to find them, it's pretty easy. If you don't, then it's not as much fun. So let's look at some examples to remind you. If I have a function f of x is equals to 6x squared minus 8x plus 2 divided by 3x squared plus 2x minus 1, and I want to find the horizontal asymptotes, you simply look at the terms of the highest powers. So 6x squared divided by 3x squared. Well, what does that simplify to? The x squareds cancel. 6 divided by 3 is 2. Your horizontal asymptote is simply y is equal to 2. Another example, let's say I have f of x is equals to 1 minus 3x minus 4x cubed divided by 3x cubed minus 8, and I want to find the horizontal asymptote. Again, my HA, simply y is equals to the highest powered term in the numerator divided by the highest powered term in the denominator. I made a mistake. That needs to be a 3. My bad. This right here power needs to be 3 in my example. And again, you simplify, the x cubes will cancel out. That leaves us with negative 4 over 3. And that right there is my horizontal asymptote. Y equals negative 4 thirds. Wow. So obviously, why did I have to change this number right here? The horizontal asymptote is not as easy when those numbers are different, when the highest power terms is different. So, for example, let's say I have f of x is equals to 2x plus 1 divided by x plus 3 times x plus 4. I think that's the first example. This is equal to 2x plus 1 divided by x squared plus 7x plus 12. When you FOIL this thing out, I need two numbers that multiply to give me 12 and add to give me 7, 4, and 3. Well, notice right here that this right here is x to the 1, while this right here is x to the 2, yes? So the denominator is higher, or has more x's. When we compare the leading terms, you can see the denominator has more power. Whenever that is the case, the denominator has more x's, the horizontal asymptote is always, underline that word always, y equals 0. Whenever we have that happening right here, the denominator is always y is equal to 0. Similarly, if I had the same case but in reverse, the numerator having more power, f of x is equal to, say, x to the 4th minus 8x squared plus 5 divided by x cubed minus 6x plus 2. Whenever you have the numerator being larger, 4x is up here, what happens? Whenever the numerator is higher, the answer is the horizontal asymptote. There is none. This is always the answer. There is no horizontal asymptote. Later on, if you do more math, you learn about an oblique asymptote. But that does not happen in this class. The horizontal asymptote is always y is equal to 0. Okay, you got two more left, your x and your y intercepts. So if I have, I can take the same function, f of x is equals to 2x plus 1 divided by x plus 3, x plus 4. Before you find the x-intercepts, you first must put the equation in its reduced form, which this equation is. Nothing cancels out in the numerator and the denominator. To find the x-intercepts, you simply set the numerator equal to 0. So you simply go 2x plus 1 is 0. Mind you, to find the vertical asymptotes, you set the denominator equal to 0. To find, after you reduce the function, to find the x-intercepts, you set the numerator equal to 0. That is because a fraction is 0 when the numerator is 0. Subtract 1, 2x is equal to negative 1, divide by 2, x is equal to negative 1. That's my vertical asymptote. In the other example, where's my function? It was 2x over. I have f of x equals 2x over x times x plus 3, x plus 5. The x's cancel. So to find the horizontal, the x-intercepts, I said the numerator equals 0. And so that means 2 is equal to 0. But does 2 equal 0? No, it does not. So this question has no x-intercept. Last but not least, you have to find the y-intercepts. And to find the y-intercepts, we have to plug in 0 into the equation of the function. So I take my function f of x is equal to 2x plus 1 divided by x plus 3 times x plus 4. I just plug in 0 and I simplify. 2 times 0 plus 1 divided by 0 plus 3 times 0 plus 4. So that is equals to 1 over 3 times 4. That's 1 over 12. Your y-intercept is at 1, 112. 0, 112. Yeah, guys, if I have an equation like this, f of x equals to, say, 2x plus 1 over x squared plus 7x plus 12, which is the same equation as this right here. When you plug in 0, you get 1 over 12 because everything from x goes away. And that right here is your answer. Yay. Now, for the other example, to find the y-intercepts, f of x is equals to 2x over x times x plus 3 times x plus 5. When you plug in 0 into this function right here, you get 2 times 0 over 0 times 0 plus 3 times 0 plus 5. And that gives us 0 over 0. Can we divide by 0? No. Therefore, this has no y-intercept. Sad face. Oh. But that's how you find your x and your y-intercept. Questions there? The other one right here is when you have your 1 over x function, in reciprocal function. F of x is equals to 1 over x right here. The graph of 1 over x is the one that has a vertical asymptote at x is equal to 0 and a horizontal asymptote at y is equal to 0, with the graph of the function being 2 boomerangs. Excellent. You are required to understand the shifting of this graph. And so if I ask you to draw f of x is equals to 1 over x plus 3 plus 2, you need to know that the plus 3 right here means a shift to the right. No, it's left. 3 units. While the plus 2 means a shift up 2 units. And so if I go back to the original graph and I shift it up 2 units, 1, 2, I will get a new asymptote right here. And if I shift the graph to the left 3 units, 1, 2, 3, I get a new asymptote right here. So this right here is x is equals to 3. Oh, not 3. X equals negative 3. Went to the left 3. And then this shifted up. So it's going to be y is equals to 2 since it got shifted up 2. So let's clarify that. The graph of the function goes this way to this way. The new asymptote, 1, 2, 3. The new asymptote, so this right here is the vertical asymptote, x equals negative 3. 1, 2. And so that's going to be a horizontal asymptote. And that's going to be y is equals to 2. And then you just graph the two boomerangs. And that's the graph of your function right there. If the number on top is negative, then you get the same answer, but you just get it upside down. So if I make a slight change, f of x equals to negative 1 over x plus 3 plus 2, this is the same graph, except it is now upside down. So again, I have the same axes. I have the same asymptotes, negative 3 and 2. But now the two little boomerangs are on opposite ends. So instead of it being down here, it's now up here. And then the other one follows suit on the other side. And that right there is the graph of this function right here. We will not be asking for about the domain and the range and the x and y and steps for these functions, but you can actually find all of those too as well. Those are pretty straightforward to find, okay? Now we have 2 more sections to cover. One is inverse functions, and the other one is composite functions. Let's do composite functions first. A composite function is simply a way of composing one function into another or inserting one function into another. So composite functions. So let's say I have 2 functions. F of x is equal to x squared plus 5, and g of x is equals to x squared minus 10. And I want you to compose f of g. I will write this, f of g of x. This means f, and you want to plug g into f of x. G becomes your variable, or g becomes your value that you are plugging into the function. So if you think about this for a second, that means that I will have g of x squared plus 5, because g is going into the f function. Well, if I ask you to find f of 7, won't that be 7 squared plus 5, because I'm plugging 7 into the function? Well, instead of me plugging 7, I'm just plugging in g, so it's going to be the same thing. Which means that I'm going to have x plus x minus 10 squared plus 5, x squared. There we go. Now, x squared minus 10, x squared minus 10 multiplied by x squared minus 10, because that's what the square means to multiply by itself. Means I gotta FOIL this out. X squared times x squared is x to the 4th. X times 10 is negative 10x squared. Negative 10 times x squared is negative 10x squared. Negative 10 times negative 10 is plus 100. Again, I have my little plus 5. X to the 4th minus 20x squared plus 105. This is your f of g of x. Now, the other thing they want you to know is that, what is it? Oh, right. They want you to know to plug values in. So if I ask you what is f of, oh, it's not f. If they ask you, what is f of g of 3? What that means is they want you to take 3 and plug it into the g function. And when you get that answer, you plug that new answer into f. So g of 3 is 3 squared minus 10. 9 minus 10 equals negative 1. I take negative 1 and I plug that into f. So I find f of negative 1. X squared plus 5. So that's going to be negative 1 squared plus 5. That's 1 plus 5. That is 6. Another example for the same two. F x squared plus 5 g x squared minus 10. I ask you to find g of f of 2. That means take 2, plug it into f, and the answer you get there, you then plug that answer into g. So f of 2, 2 squared plus 5, what's 2 squared? 4. That's 9. And you take 9 and you plug 9 into g. G of 9. 9 squared plus 5, 81 plus 5, 86. There you go. And that is your g of f of x and your f of g of x and your composite functions when you have to plug one function into another. Excuse me. The last section that we have is your inverse functions. Why am I so tired? Now your inverse function has 3 sections to it. But before you need to go any further, we just have to remember what the inverse function is. If I define a function f of x as a set of ordered pairs, 1, 7, 2, 9, 3, 11, and I want to find the inverse of this function denoted by the negative 1 as the power. Notice that this negative 1 does not mean to flip or make it upside down. This simply means the reverse function. All that means is I have to take the x and y values and switch them. Notice I didn't say make them negative. Notice I didn't say take reciprocal. Nothing. All you have to do is make all the x's y's and all the y's x's. That is all. A lot of people overcomplicate the problem for some reason. I don't know why, but that's how you find the inverse of a function. So I remember I said there were 3 sections. This is actually the first section, and it's normally one of the easier questions on the test. But for some reason, people forget or not paying attention or worried about something else on the test, and then they just miss this altogether. Don't make anything negative. Don't switch signs. Don't flip stuff. No, don't mix and match. Just take every x, make it a y, and take every y and make it an x. Just flip them, and that's it. The interesting thing is that when you have a graph and you have to find the inverse of a graph, you do exactly the same thing. So let's say I have a graph right here. Let's put some points. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So let's say I have a graph that goes through -3, 2, -2, 0, 0, 1, and 3, 1 right here. I'm asked to find the inverse of this graph. All I do is I go, the graph right here has these ordered pairs. -3, 2, -3, -2, sorry. -2, 0, 0, 1, and 3, 1. Then the inverse function will have the same ordered pairs but flipped. -2, -3, 0, -2, 1, 0, and then 1, 3. You just plot those points. That's it. You have the inverse of the function. So -2, -3 is right here. 0, -2 is right here. So you see this point corresponds to this point. This point corresponds to this point. And so forth and so on. The next one is 1, 0. And then the last point is 1, 3. And of course, you connect those. And that gives us the graph of the inverse function. The only thing that you need to be aware of is that mathematically speaking, the inverse of a function is the reflection in the line y is equal to x. The line y is equal to x is a 45-degree angle line that goes through all the points where the coordinates are the same. So for example, this point right here is 3, 3. This point way down here is -3, -3. If I take the white graph and I flip it in the line y equals x, I will get the green graph. That's all there is to find the inverse of a function. Now the last way of finding the inverse, and the funnest way of finding the inverse, I think, is when you have to find the inverse using algebra. I think I'll do 2 examples, maybe 3. Let's say I have a function f of x is equal to 3x plus 2. Yeah, this example, by the way, is way too easy. You never see this on the test, which is good for starting out. And I want to find the inverse. First thing I do is I change f of x to y. Since I'm doing algebra, it's just a little bit easier if I have everything in terms of x and y. Next is I switch x and y's. Remember up here, when you find the inverse, you have to switch the x's and y's. You do the same thing here. Everywhere you see y, you write x. Everywhere you see x, you write y. And then you simply solve for y. So I got to get this y by itself. So I got to get rid of the 2 and the 3. I will subtract 2 first. X minus 2 is equal to 3y. And then I'll divide by 3. Y is equal to x minus 2 over 3. And this right here is my inverse function. X minus 2 is 3. Now this is obviously the inverse function because it does the opposite of this function. See how the original function added 2? This function is now subtracting 2. See how the original function multiplied by 3? This function now is dividing by 3. That lets me know that it is the inverse function because it's reversing the operations of the original function. Next example. Let's say I have f of x is equals to 3 times x plus 2 squared minus 7 for x being greater than or equal to -2. And I need to find the inverse of this function right here. We'll get to this piece in a second. But this right here is simply the domain of the function. It has one key role in helping us find the inverse. And as you see as we go along. So, first step number 4, change f of x to y. So y is equals to 3x plus 2 squared minus 7. Yeah, the domain doesn't play much of a role yet, so we don't use it. Then, just like before, you switch x and y. So everywhere you see y, you write x. Everywhere you see x, you write y. And then you solve. So I'm going to take the 7 over for y. X plus 7 is equals to 3 times y plus 2 squared. So in this original problem, I'm subtracting 7. The inverse is going to add 7. See how it's working the question problem backwards? Then I'm going to divide by 3. So I have x plus 7 over 3 is going to be equals to y plus 2 squared. Now to get rid of a square, I have to take the square root of both sides. I got a radical here, I got a radical here. So y plus 2 is equals to, now this is where this piece comes in. First, let me remind you, the square root of 16 is plus or minus 4, right? When you take a square root, normally you get 2 answers. So in theory, this should be plus or minus x plus 7 cubed. But if I had the x plus or minus right there, this is no longer a function. So I have to make a determination. Is it going to be a plus or is it going to be a minus? This is where this comes in right here. When x is greater than 2, am I going to positive infinity or negative infinity? Am I growing or am I getting smaller? You're growing. And because you're going to positive infinity, because x is larger than negative 2, this is going to be a positive root. Of course, I don't need to write the plus sign down. I need the minus sign. And so you use just square root on both sides. 7. Of course, the last step is to then subtract 2. So y is equals to the square root of x plus 3 over x plus 7. Over 3 minus 2 after I subtract 2 on both sides. And that right here is my inverse function. This function right here does the opposite of all the other functions that we've had before. And of course, that makes your life so much easier. Yay, yay, yay. So in this original problem, I'm adding 2 at the beginning. I'm subtracting 2 at the end. See how I'm squaring? Now I'm taking a square root. All right, last example for the day. The hardest problem, and the one that gives students the most issues, is when you have a fraction. Let's say I have f of x is equals to x plus 3 divided by x minus 7, and I want to find the reverse of this function. I want to find the inverse of this function. I need to walk around some more. Change f of x to y. So y is equal to x plus 3 over x minus 7. And then, just like before, I switch x and y. So everywhere I have y, I write x. Everywhere I have x, I have y. But that leads to a simple problem. If I am solving for y, how can I solve for y when I have 2 of them? Do pray tell. And the way we work around that right here is we have to first get rid of the fraction. So you multiply both sides by the denominator of our fraction. These will cancel out. So y minus 7 times x is equals to y plus 3. Notice I still have 2 y's. I distribute the x. xy minus 7x is equals to y plus 3. xy 7x. And what I have to do is I have to then gather all the y values together. So I'm going to take the 7x away. So xy is equals to y plus 7x plus 3. And then I'm going to take the y over, minus y, minus y. So I have then that xy minus y is equal to 7x plus 2. So what I have essentially done right here is I have brought the y's together. And now that I have done that, I can just factor out a y because everything has y in common. So I go y, open parentheses. Don't forget there's a 1 right here, yes? So then it's going to be x minus 1 is equal to 7x plus 2. Y times x is xy. Y times negative 1 is y. But by me factoring out this y, I go from having 2 y's to just 1. The last step is to then divide by negative 1. So y is equal to 7x plus 3 divided by x minus 1. And that is the opposite of the original function. Now, interestingly enough, for fractions, it is not as obvious as why this right here would be the opposite of this right here. But we worked it out, and so it is. And with that, I bid you adieu. You all have a lovely day. If you have any questions, you can let me know. Can you hear me? If you have any questions, you can just let me know by sending me an email. Okay.